Hello, hello. Hopefully people can hear me properly. Hopefully my mic doesn't sound bad. I can't really tell. Someone wants to enlighten me in the chat and let me know how everything sounds. That would be great. But welcome to GitHub 101. Uh, Obviously, I'm not sure. Everyone isn't shutting up about it in the chat. I'm part of LCS, one of the VPs of operations on the admin team. And today we'll do a little workshop on Git and GitHub 101. We know a lot of people really like to learn about Git, kind of a really important thing, and I think everyone should know about it. But before we begin, like throughout the stream, there will be a QR code in the bottom right of the screen. If you are a Laurier student specifically, it might be worthwhile to scan the QR code and sign in so that you get on your Laurier experience record and you can become a general member. But I'll also bring up the QR code here. I'll just give it a couple of seconds to sign in, just in case the QR code at the bottom right is really small. And I don't really know if the music's too loud or too quiet as well. And relative to my voice, I can turn up and down, but yeah, just feel free to sign in. In the meantime, how's everyone doing tonight? It's pretty dark, pretty hot outside the last few days, so you know. But yeah, thank you very much, Mina. But yeah, thank you. But yeah, I know a lot of people. Thanks, Abdullah. I mean, good to hear, Abdullah. Glad to hear that you're great. But yeah, but one of the reasons for this workshop is that like a lot of people, especially in computer science and maybe other related fields, stuff like Git isn't taught in. Well, actually, recently it has been taught in some classes, but it's not as crucially taught as it should be. So it's one of the workshops that we really want to like really throw at you and show you like, hey, this is something that's really cool, so you should kind of learn it, and you know, maybe give you a little demo of it. You might not necessarily learn everything about Git or how to use it, but you might have like a rough idea of where to start. So yeah, anyway, wrong slide. This will be kind of our agenda of what we'll be talking about today. So we'll start off talking about Git, what Git is. Funny enough, one sec. Relative to, sorry, I think someone was saying my mic is a bit quiet, so let me know if that's a bit better. Hopefully it's not peaking or anything, but yeah. Yeah, but anyway, so today we'll be talking about Git. So Git, very cool software, very cool thing. And then we'll be talking about GitHub, which surprisingly are different things to each other. Oftentimes they're confused with each other or used interchangeably, especially by people who are like newer. We'll be talking about some key concepts of the entire idea of Git, and then we'll be doing a little demo. That'll be like the main focus of the presentation, I guess, is the demo on how to use it. You might not necessarily be able to follow along, like, you know, one by one, especially if you're new to this type of thing, but it might be just a good way to get yourself introduced to it. And let me just quickly turn on the light. There we go, that's a bit better. And then at the very end, we'll link some resources, we'll take questions. We have a bunch of resources on this type of thing. And there's like tons and tons of resources about open source software, as well as like resources learning Git, so we'll get into those. But the first thing we'll talk about is what Git is. So if you ask Google what is Git, or you search it up and you look at the Wikipedia page, this is the really boring definition that you get. It's a distributed version control system that tracks changes in any set of computer files, usually used for coordinating work amongst programmers. That's pretty boring. A lot of big words. I don't kind of get it, and I've been, I know English. So, what Git really is, it's a version control system. So, think of every time you're on Microsoft Word, or sorry, let's just use a better example. Every time you're on Google Docs, because we're in the modern era. Every time you're on Google Docs, and you see like, hey, like you've just made a change, maybe this other person made a change, and you can like look through the entire history of who changed what. And you can even maybe go back, just in case you accidentally delete everything on the document. You can easily go back and undo it. That's kind of what a version control system is, but on the scale of like entire folders and files. Because oftentimes, you might be working on a huge code base, or making a project, and or even you don't even have to use it for code. You could be writing like a bunch of docs in like LaTeX or something, and you accidentally delete everything from your computer, and your recycling bin was already too full. So it gets permanently deleted from your PC. In that case, you're kind of screwed. So in that type of instance, like a version control system is really useful. Being able to, there's a lot more complexity to it too. You can like see who did what. You can see when it was done. You can see like an entire history of like how people like evolve the code essentially. It's really cool. There's like a bunch of cool tools for it too. But yeah, mostly Git started off as a command line tool, and it still primarily is a command line tool. So a command line tool being something that you would look at, like open up a terminal or like a PowerShell, like a Linux bash terminal or something, and you'd write a bunch of stuff in there to use it. But there is like more modern ways of using it too, and easier ways as well. And lastly, Git is an open source project started by Linus Torvalds, which is a very big name, very famous guy. I think he started Git back in like 05 or 06, so probably a bit older than some of you guys. But yeah, it's basically, that's like a very brief summary of what Git is. Now we'll get into like where you can find it. So Git, again, very separate from GitHub, which we'll talk about later, but exclusively Git itself is the actual software on a person's computer. So when I talk about Git, I'm talking about like an actual piece of software on your computer as opposed to like a website or something. Like there's no git.com. Actually, there might be, but there's no website called Git. Like it's an actual piece of software on your computer, and you can usually get it on all operating systems as well. And usually you interact, as we said before, you interact to it with a terminal. And modern day and age, you can interact to it. You can interact with it through GUI interfaces, like graphical user interfaces, such as like VS Code, which you guys have probably heard of. Some of you guys have probably also used Eclipse in your classes, and Eclipse also has built-in Git integration, so you can manage the entirety of Git through Eclipse. There's also like software specifically made for managing Git repos, like GitHub Desktop, which also is like a very beginner-friendly piece of software. And also Git, the people who like keep up Git, wow, there's a lot of people following, thank you. The foundation, that the open source foundation who manages and maintains Git, they also have a package called Git GUI. It's very bare bones, looks like it's from the 90s or something, so I wouldn't recommend using it. But it is a built-in GUI tool that you can use to like visualize Git stuff pretty easily. So what does Git do? This is a more technical word. So these are some words you'll see throughout the presentation. Wow, a lot of people are following. Thank you. But basically, it's used to manage local repositories and push-pull updates to a cloud-based solution. So there's a lot of big words there again. Essentially, what it lets you do is you have your like folder or folders of files or code. You can manage those files. You can track your changes to them using Git, and you can like basically package changes into small chunks, and then you can push all of that to some server or some like online solution where other people can also look at it as well, which is like kind of where GitHub comes in later on, as well as other things. But that's kind of the job of Git. There's a diagram here too at the very bottom right, or bottom left, where you can see like your workspace. So this would be like code that you locally have on your computer, whether that be like some project in Python or some project in C. Like the point of Git is that the actual content doesn't matter. It manages any type of file, so it could be literally anything. And then what you can do is you can like stage your changes. And again, these words I'm using, confusing at first. We'll go through a demo later, so it won't be as confusing. But then you can add your changes and stage them, which essentially means like, let's say you did like 3 different things to your code, you completed 3 different tasks pertaining to your code. You could basically stage 3 different sets of changes. So like, let's say I added a new icon to my website, and there's like a bunch of code for that. I could add all the files related to that change using the git add command. And I could stage it with a message and commit it. So committing is actually like kind of adding to the history, like making it official that I actually like, maybe added image to my website. And then I could add a bunch of other files related to, like, let's say I also added like a navigation bar to my website. I could add all the files related to that change, commit those with a message as well, saying like finish navigation bar, and then commit that. So again, diagrams hard to follow sometimes, so it's not a big deal. But let's say you have a bunch of changes you've committed now, and you want to push them to like GitHub or some other server or wherever on the internet. That's where these commands come in: git push and git fetch. And then there's a bunch of other stuff here too, but we'll go over that later. Not a big deal. Again, diagrams hard to follow, so don't worry. So there's a little tidbit. Git is the most popular version control software. It has a market share of like 90%. Honestly, it's more like no one uses anything else but Git. The people who use anything but Git are like in a huge minority, who are like very niched people. So you're never gonna hear somebody of using any other software. Like there's one called Mercursion or something. I forgot the name. It's like really fancy sounding. But no one actually uses it. Everyone uses Git. So like there's no point. Like once you know Git, you're basically set for version control. So yeah. So GitHub, that's the big name that you've probably heard a lot of, especially in the news every now and then. So basically, GitHub is a Git repository hosting service. So essentially, I'll mention this later too, but without an online service to store repos in, your code kind of just, even though you're using Git, it would just sit on your computer, which isn't that useful, especially when you're collaborating with other people. So websites like GitHub and others allow you to like push that code, all the changes you've made and committed, to some server so that other people can also edit code, push code, look at it, and then they can also push it to that server too, and then back and forth, and that's how you work in a team, like in a software engineering team, right? So yeah, that's kind of what GitHub is for, and there's a lot of other solutions too we'll talk about as well. So basically, yeah, exactly. Without cloud-based solutions, repositories would just be sitting on people's own computers, which isn't that useful to anybody, right? So yeah. So right here, we can see that, yeah, big companies use GitHub privately or have their own solutions internally. So if you've ever heard of like someone who works at a software engineering job or something, they'll oftentimes have their own repos internally too. So like companies like, Netflix, Google, Amazon, they probably have like thousands and thousands of repositories for different projects they're working on. Personally, my last co-op, like the company had like 10,000 repositories, which is insane. And by the time I left, it was like 13,000. So it was like 3,000 repositories in like 8 months, which is insane. But yeah, like companies oftentimes also use Git. So that's another thing. Like obviously Git is really useful for your school stuff, but it is something that's literally used by everybody in the industry too, whether that be software engineering or even like researchers use Git. A lot of my friends, like I have a friend from U of T who runs a lab doing his PhD. His lab uses Git extensively too for all their stuff. So yeah. And here we have some examples of other cloud-based solutions that are, I guess, competitors to GitHub, like GitLab and Bitbucket. Those are also some names you might have heard of. But yeah, they're, again, the majority of market share, just like Git, is had by GitHub. People always put their GitHub URL on their resumes, not their GitLab or Bitbucket. Really rarely does that happen. So I'm not saying that anything bad with that. GitLab is actually really nice. I like GitLab. The UI is really pretty, in my opinion. But GitHub just has like a huge market share monopoly, so yeah. So these are some key concepts we'll be diving into about Git specifically, like how to use it and stuff like that. So we'll be talking about how to initialize a repository, how we add files to a repository, how we record changes to it, and then how we push local changes to the remote repository. So that, again, in the diagram you showed earlier, once you have all your changes finalized on your computer, you want to push them to your on the internet GitHub repository. So that's what that is. And also, let's say like a bunch of other people are working on your code with you, and like they've made a bunch of changes as well, and they've pushed them to that repo as well. And now you're like, oh shit, like I want to work on the stuff that they're working on or look at it. How do I do that? You can just pull their changes from that repo, and then now they're on your computer too. So that's kind of like the whole idea of version control as well. You can also look at the status of working trees. So working trees are kind of like a concept that we'll talk about later. But essentially, for anyone who's done any sort of data structures, repositories are like modeled with trees, not binary search trees or anything like that. So don't worry, very basic trees, just regular trees. But like with a tree, and like a real tree that has a lot of roots, but it starts with like one bark, I guess, or one base, I guess, whatever it's called. That's how like GitHub repos or Git repos in general work as well. So, and exactly, like some of the wording as well for Git concepts is directly correlated to trees. For example, list, create, and delete branches. Like that's an actual word in Git, branch. So yeah, a lot of the concepts are directly related to trees. So yeah. So this is kind of sorry about that. So this is kind of an example of like how this is like very complicated looking. I can kind of understand. But essentially, on the very left, we have like a yellow box that represents a commit, and a commit is kind of like in a timeline. Like if you ever look at a timeline, and it's like let's say you look at like a timeline of like a past event or something, all the dots that like tell you different parts of that timeline is a commit. So like in your life, for example, you being born would be the first commit. You going to school would be another commit. Stuff like that. So commits are like snapshots of history. And in commits, you can have like a bunch of changes, a bunch of files, different versions of files, this and that, and you can like look through them and a bunch of stuff like that. So, yeah. So two things we'll be talking about as well later on is how to make a new repo. So making a new repo is pretty simple actually. You don't have to do any code for that. It's just clicking a plus button on GitHub. And obviously for the demo later, we'll be using GitHub and Git. We're not going to be using like GitLab. So for anybody who wanted to see, anyone who wanted to see GitLab or Bitbucket, sorry about that. But yeah, we'll be talking about forking and cloning. So when you look at someone's repo or like you make your own repo, whatever it is, or for example, like oftentimes I've looked at someone's repo and be like, oh, I want to like do that, but then edit it slightly, and I like, want to do it for myself, right? That's called forking. So forking is when you create a personal copy of someone's repo to your own account. So on GitHub, you have accounts, obviously. So like, you know, every account can have as many repositories as many repositories as they want. And let's say I find like, I don't know, Shakib's repository on GitHub, and I'm like, ooh, that looks cool. I'll clone it to my account, or fork it to my account, sorry, which basically takes that entire history of that repo and transfers it to a repo on my account with the same name, and it retains the history, but they're very different. So like, let's say if Shakib like adds changes to his repository after I forked it, I won't get those automatically. Like they're not synced or anything. They're kind of completely detached. It's kind of like you took an exact picture of Shakib's repo, put it on your account, and now you have that picture, but the pictures aren't like magically related. So yeah, you can sync them throughout time though. There's like ways to sync. Like let's say you forked a repo from like 10 years ago, and you come back to me like, wow, like this repo is so old, and the actual original repo is so far ahead. I want to like sync that and then work on it on my own. So you can easily like sync changes between forked repos. And then cloning is another big word that you've probably heard, or maybe heard every now and then. Cloning is the idea that, let's say either you have a repository on your GitHub account, or you find someone's repository online and you want to work, like you actually want to code on it or work on it, and then like do whatever you want with it on your computer. That's called cloning it. So when you clone a repo, you're taking it from that person's like GitHub account or whatever, and it copies all the code to your computer into a folder, and then from there you can do whatever you want to it. And that's where like the whole GitHub stuff or Git like version control comes in, where you can use a bunch of fancy commands to do stuff with. So yeah, these are some more concepts that we'll be using. So staging, pulling, pushing, and committing. So we again touched on these kind of a lot, and I keep reiterating the same points, but there is a lot of words that come up in GitHub that are like you don't usually use in day-to-day terminology. Like I don't usually use the word commit or push or pull a lot. So it is a bunch of new concepts all at once, so I'm going to keep reiterating what they are. But staging is basically preparing changes for a commit. So whenever you add a file, let's say you change something in a file, you can add it to your like stage against. Like, you can think of an actual stage, like in a auditorium or something. You add all the changes that you want to the stage. You can also remove changes. Let's say you add a file to the stage, but then you're like, oh shit, I actually don't want to commit this. I'll do it later or something. You can remove it. It still keeps the changes. It's just they're not like staged essentially. They don't have the focus on them. So that's what adding and removing is. And then once you've added all the files you want and stuff like that, and you've deleted it, everything looks good, you can commit it, which actually like records and solidifies all those files to the actual repository tree. So that would be where you add a message that kind of documents what all those files were changed, like why they were changed or how they were changed or whatever. So if, again, the example I used earlier, if you added an image to your website, I would add the file, the PNG file, I would add the code related to that change using the git add command, and then I would like write a commit message, added image to website, and then commit that. So once I've committed that, my local repository is like has that change recorded, and it's like official, I guess. It's like actually there now, but it's not like the website, like GitHub repository online doesn't actually know that I did that yet. So that's why you push stuff. So once you've made a commit or several commits, you basically can push that commit like to the remote, it's called the remote repository, and now the internet GitHub version of your repository is up to date with what you just added. So yeah. And later on, let's say someone else like Jesse, he adds some changes to Shakib's repo, and he pushes some stuff to Shakib's repo on GitHub. Shakib's computer isn't automatically going to know to get those changes, right? Because it's not like Jesse's computer can just talk to Shakib's computer. So what Shakib can do is he can pull those changes from the repo he has, and it'll tell him like, oh, yo, like Jesse added some files, here they are. Like this is all the changes he made, these are all the commit messages, blah, blah, blah. So yeah. Can I put my face on the top right? I sure can. One second. Very smart guy. There you go. Perfect. Yeah. So these are some commands. Again, we'll go over these so you don't have to actually memorize them or anything. And yeah, cool. So these are, I wouldn't say like more crazy or complicated concepts, but these are like past the basics, basically. Branches and merging. So essentially, let's say you're working on a huge project, like you're making the next Netflix website, let's say. And you have like different folders that do different things. So like you have a front end folder that has all the front end code. You have like a folder that has all the streaming related code. You have like a folder that's related to like managing accounts and stuff. And let's say like 5 of you working on this, like it's really hard to just all work on the same set of code essentially. Even though you guys might be touching different files, every once in a while you might touch similar files, and that can kind of get messy. So basically what you can do is you can have like branches that like you can branch the code. So like let's say if you think of the Git repository as like a tree with one like branch underneath or one root, whatever, or yeah, I guess one branch. Every time you branch or make a new branch, you're basically like you're taking a copy of the current state of the repository, kind of the same way you'd fork something, and then you're like adding on your own changes to that branch without disturbing like the main code. So oftentimes, especially in companies and projects, you'll have like a main or master branch that is like the actual project itself that's final, and then you'll have like a branch for each feature someone's working on. So let's say I'm working on the streaming part of the website that like handles video encoding and all that. I would make a branch called like streaming encoding or something, and then I would add all my changes for my code into that branch. And then once I've like done all the changes to streaming, let's say they're ready to go, people have tested them over and over again, and this branch is ready to go, and I now want to like put it back into the main branch. That's where merging comes in. So in this diagram right here, the master branch is the actual Netflix products, let's say, and then I make a branch right here for streaming, and then I add a bunch of commits. So these dots represent commits and stuff, by the way, and events. Let's say I add a bunch of commits to my branch over here. So like I work on it, blah, 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 and I'm done now. So I'm at this blue dot right here. Now I merge it back into master once it's been tested, when it's fully ready to go. And my branch, like now master or the main branch has all those changes. But if I were to just like make those changes straight onto the master branch, I might commit code that's like really bad, or like I might just commit code that breaks stuff. Or I might just like commit stuff that hasn't been tested or isn't ready yet, right? And then other people might work on it too by accident. So that's why keeping branches for different features is a really good idea, especially in like a really big project. And even if like let's say you're working on a personal project, you might think you might not need branches, but it's really useful to like maybe separate your code into branches. Because let's say you like abandon a project for 4 months, which is like very relatable to a lot of people who program, and you come back to it and you see like 100 different files that were added like last time you were working on the project, but they're all in one big commit, and they're all like different things. Like it's really hard to like kind of separate what's what. But if you have like branches that were like made beforehand and they were committed, you can like kind of follow the history easier and see like, oh, these 10 commits are related to streaming, these 10 commits are related to the front end, blah, blah, blah. So that's why branches are really useful. So again, we talked about this already, but creating a new branch allows other developers from modifying the main branch through their own merges. So again, most of the time you have a main branch that never gets commits put onto it directly. You usually make your branch, which is your work right here, the blue one, and you make all your commits here, and then once you're ready to go, you can merge it back into main, and like it's more organized, more clean, and there's different ways to like handle merging too. As you can see in this diagram, like when you merge this green dot again, it's only one green dot, but you had 3 blue dots, right? So you had 3 commits, but they all become one commit on the main branch. There's like different ways of handling that so that it doesn't like, there's like, basically it's called squashing your commits into one. It's pretty obvious why it's called squashing. Let's say if you have 20 commits, it'll squash them to one big commit. But there's different ways of handling that. Let's say you do want to squash stuff, you can do that. If you don't want it, if you wanted to preserve the history entirely and just like kind of copy it back to main, you can do that too. But then obviously there's different ways of handling it, which also leads to some issues every now and then. So if you are working on the same thing, like let's say you and a buddy are working on the same branch, you might edit the same files, push them, and then commit them and stuff like that. But then someone else on the main branch already edited something, blah, 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 like this merge conflicts. It's a very common thing in a big project. So yeah, we're not going to cover too many merge conflicts today because like, that's kind of a pain in the ass even for me. So now this is the part of the presentation where we do the actual demo of how to use Git. I don't think there's any questions so far, but feel free to ask anything. Yeah. But yeah, we'll load up like GitHub, show off like how to make a new repo and stuff like that. All the basic stuff that we kind of covered in the presentation. I'm just gonna pull up some notes. There we go. Cool. So first console, this is GitHub. When you log in, when you make a new account, you log in for the first time. It'll look like this, but a lot less messy because I obviously have stuff like on my GitHub account. But ideally, you have like nothing if this is a new GitHub account. If you want to know how to make a GitHub account, you can do that on your own. Just Google how to make a GitHub account. I don't need to go over that. But once you're here, you have a nice little plus button here for new repository. There's a bunch of other things here too, which are like once you get used to how to use Git, you'll probably be using those later on. Almost use that Laurier hotkex in the left corner. Yeah, it is. Little wink wink hotkex. Anyway, so new repository, simple as that. And it's pretty simple to make a new repository. It'll just ask you like, oh, what name do you want to give your repository? It's, your new project that you're working on that you're probably going to abandon after a week. You can give it a brief little description. And the cool thing is you can make private repos too. So if you're making like the next, if you're working on the next Facebook replacement and you don't want anybody to know that you're working on it, you can just set a repo to private and then no one else will see that you're working on it. But again, if you're working on projects that aren't, like most projects you're working on have probably been made before, so there's not really a big point of making them private unless you're doing schoolwork or something. And then this is a button here that says add a README file. So every time you look at a repo, there's a nice little like, I guess, description of what the repository does, and you can customize the description to look as pretty as you want. That's all done in a README file, so you can either generate that or not generate that. I'd recommend generating that and just adding like the basics of what your repository is about. And then add a git ignore template. You can ignore this for now, but essentially I'll explain what git ignores are later. But for now, like if you're working in JavaScript or something, I would recommend searching up or like Node.js, sorry. I would search up Node. If you're working on a Python project, I would recommend searching Python and like using that template. There's usually a template for every really big framework or every main programming language. There's also some things here that I've probably never heard of before. But yeah, if you're working on a project specifically in specific code language, just choose that from here. So otherwise, for now, we're just going to leave it empty. And then license. So this is a big thing, especially with open source projects, is licensing. As you can probably figure out, you can't just like, if you're like a big company, you're like $1 billion company, and you see some guy who has like a really cool repo that's a really cool project, you can't just fork that repo onto your business account and then sell it as a product. There's like rules around what you can do, how you can copy people's code, how you can't. And there's a bunch of licenses you can choose from that are pre-generated that basically tell people when they look at your repo like, hey, this is my code and you might be able to use it, you might not be able to use it, and these are the rules around it. Like, do you need to pay me? Do you need to like shout me out in your project, whatever. So I would recommend, if you are looking on like a cool project, looking into what license to use. There's a cool website actually, if anyone can find it. It's like, one second, let me search it up. Just quickly find it. It's, yeah, is it this one? Nope. This is a really cool website, choosealicense.com. So this website's really cool. It tells you exactly like what each license is, how it works. And there's like basically buttons you can click to like, or it'll tell you like, hey, like these languages usually use these licenses. And these are like, if you want to work in a community, if you want it to be improvements or stuff, or like there's other stuff here too. So it's a really cool website. Describe some stuff. But yeah, after you've done all that, you click on create repository. We're not going to do that because we already have like a blank ready to go repository for this project. So we're gonna skip that, but ideally you click create repository, and once you do that, you'll get taken to your newly created GitHub repo. So this isn't completely empty. We added some stuff to it before the presentation for obvious reasons. So as you can see, this is what a repository view looks like. There's a bunch of buttons everywhere, and I'm still get confused sometimes about what each one does, but you can ignore it for the most part. Fork is if you want to fork the repo. Watches if you want to get notifications about it. Stars are kind of like the equivalent of like liking on something on Instagram, basically. And then if you have more stars, I guess you're cooler or something. And then you have your README file. So if you generated a README in that beginning prompt, I guess, you'll have an empty README with just the name of the repo. You can go ahead and edit this README to make it look as pretty or as ugly as you want. And it uses Markdown as like the syntax for writing text. And if you don't know what Markdown is, it's like a really simple way of just laying out text and making it look pretty in images. So some examples of really cool repos that I have that have really cool readmes, courtesy of our VP dev at LCS called Aiden. But he generates really cool readmes for repos. So as you can see, this is the README for the website that we have, the LCS website. Nothing crazy, but just a nice little thing to look at when you scroll down, and it has some instructions for people who might be interested in contributing on like how to like, you know, do stuff. Show the Julia sets one. I think the URL is Julia. I think. Yeah, so this is the Julia sets, the project that me and Aiden did a while back. It has like a bunch of description stuff. You can embed code in here as well, so it looks pretty. You can show off different like screenshots and stuff like that too. So yeah, really cool way to like demonstrate what your code does without actually like having to make people like look through your code and read it. Even if it's a personal project, I super recommend having a README, because like even people are impressed by looking at these pictures, right? Everyone likes pictures. So yeah, cool. Anyway, let's README. If I go back here to this main repo again. So this is a brand new repo. We'll imagine that it's never been touched before. So now I'm going to go to my terminal on my computer, which is just empty right now. And again, I'm going to be using the terminal to interact with Git. But oftentimes people who are brand new might be considering using GitHub Desktop. And if you're going to use GitHub casually, that's cool. Like you can use like a GUI software to use Git. But if you're going to be using Git for a while, like if you're actually going to CS or something, I recommend definitely like investing in learning how to use the terminal specifically, because after a while the terminal is actually a lot quicker to use than like a GUI. Learning the CLI is really important, especially when you go into like jobs and stuff. So I'm going to be using the terminal for the majority of this presentation. But the first thing I'm going to do is, this is my new repo that I've made, brand new. It's my own repo. I'm going to copy the link to the repo. Just going to Control-C it. And then the very first command we're ever going to learn together is git clone. So we talked about cloning. It's how it also makes you feel like a hacker, man. That's true too. Anytime someone walks into your room and you're coding, and they'll be like, "Whoa, what's that?" And you can just be like, "Yo, like, you know, I know stuff, right?" So anyway, you have the repo URL copied. Git clone is the first command we'll be using. Again, it'll copy the repo from online and put it onto your computer. So if I just paste the URL in, click enter, it'll give me some text. It'll tell me how long it takes. And now this repo has been cloned onto my computer, and you can check if I press ls, if I type ls, which is the command to list directories in a terminal, it'll show me that I have this new folder called Git 101 now, and I can go into that folder using cd. I guess this is also a very basic CLI tutorial on how to use the command line, but ls list directories, and then cd goes into a folder. So yeah, cool. Anyway. Now you can go to this folder right here, and you see all these cool little symbols. You're like, oh, what are these? It looks so wacky, blah, blah, blah. Ignore these for now. I'll explain later why they're here and what they do, but for now, just ignore it and just look at what I'm typing. So if I type ls again, now I'm in the Git 101 folder that I just made or cloned. If I look inside this folder, I can see I have two files, readme.md and docs, and that's exactly what we have in the actual repository here. We have docs and we have readme.md. So you know you successfully cloned it. There's no way it wouldn't have successfully cloned, or else it would have told you it couldn't successfully clone it. So yeah. Anyway, I'm gonna open up this folder in a Visual Studio Code instance. So again, if you're like a beginner and you've only done like a bunch of CS classes, specifically at Laurier, you've probably only used Eclipse, which is totally fine. But Visual Studio Code is kind of like the default for most people, and that's what I'm gonna be using. It's pretty simple to follow along with what I'm doing. Nothing in this tutorial is going to be like code specific. You don't have to know Python. You don't need to know how to multiply matrices together, so don't worry. But basically, I've opened up the folder that I cloned originally. As you can tell, I'm in the GitHub 101 folder, and I have the docs folder, and I have the README file that we cloned earlier. So basically, we'll be making some changes in here and demonstrating how they work. And most people might be like thinking like, you know, there's a terminal in VS Code too. I can open up the terminal in VS Code and use that. And that's totally fine. All the things I talk about, you can just do in any terminal at all, other than like Windows PowerShell. Windows PowerShell is really shit. But you can do it in any terminal at all. But I just prefer using like an external terminal. It's just a habit of mine. So I'm going to be like making changes on my code and then looking at them over here. So yeah. But let's say I'm working on a brand new project. I'm gonna make a new folder and I'm gonna call it source. I'm gonna make a new file in here, call it main.py, and I'm gonna make the next coolest program. So I'm just gonna pull up some code I have prepped. Boom. So I've made this cool function that checks if the number is even, and I'm like, wow, this is really cool. I like spent half an hour working on this. I need to make sure that I save these changes, and but actually let's just say that, like, oh no, like I added a bunch of changes to this, and I want to undo all of them. I don't know what I did. I just did a bunch of shit. I want to undo it completely. I want to go back to when I first cloned the repo. One of the coolest commands you'll learn, also one of the most dangerous commands you'll learn, is git reset hard. And what this does is it completely, why didn't it? I don't know why that didn't work. But usually that would undo all of my changes and go back to where I was before. But I don't know why it didn't work. That's weird. Anyway, we'll continue forward. He reset hard. That's not funny. Anyway, ignoring that, let's just say I have this code now that I added to my repo. And as you can see in Visual Studio Code as well, it has like basic Git integration. So it'll show you like stuff that's green usually means that you've added it. And it's like brand new and you should probably commit it or add it or something. So let's say I want to commit this now to my repo on GitHub and show everybody that I know how to code an isEven function. If I do git status will always tell you what's up with your repo. So the first line here tells you what branch you're on. So our project only has a main branch. By default, when you make a repository, there's one branch and it's called main. For most small projects, you'll only ever use one branch. And it tells you right here, your branch is up to date with origin main. So what this means is that your branch is as new as the branch that is on the GitHub repository. So the code here is up to date with the code here. The code here on your computer is up to date with the code here. That's what that tells you. So origin specifically means like wherever you cloned from, the origin of your code, kind of. So now we know that we're on main, and we know that all the code in my computer is completely up to date with what's on GitHub. And the next thing will tell you untracked files. This will tell you all the things that have been changed on your repo, but you haven't done anything with them yet. So if I add another file too, let's quickly add another file. Let's call it test.py. Let's just make a function called hello world or something. So let's just say I have this right here. Oops. And I have this new file as well. Now I have two files in here. If I do git status again, as you can see, if I go into the source folder first and then I do git status, wow, this is really a bad example, but anyway, as you can see, there is a bunch of changes. So now what I can do is, these are untracked files. What I can do is I can do git add and then the name of the files that I want to like commit, basically. So I want to commit main and test, for example. I could type in the paths and the names of the files. So I could do like source main.py, and I could do like source test.py, which works fine. But let's say you like change like 10 files just now and you don't want to type the names manually. A cool shortcut that I like to use a lot is just dot, which just adds all the files that are new. So that's done. Now if you do git status again, you can see that it detects there's two new files that are staged now. So it even tells you like, hey, changes to be committed, use this command to unstage. So it says unstage, which means these are on the stage right now. So these are like the files that are focused. So let's say now I staged these, but oh shit, I just remembered I need to add like one more thing. I need to add some more code. So let's add like one more condition. Let's add 11 instead. Return false. So I added that. I'm like, oh man, I need to, is it okay if my commit messages are paragraphs? That's a good point. I'm gonna explain that in literally 1 second. So basically, now I have this new change right here, and I want to add it to the current changes that I'm going to be committing soon, right? If I do git status, it'll tell me, oh, these are two files that are new, but you have this new file that has some changes that have been modified, and you might want to add those too. So you can do again is you can do git add dot again, and if I do git status one more time, now you can see that there's only two files that are ready to be staged again, and now it has both of these files ready to go, and you can see that because, yeah, okay, anyway. But yeah, now you have those two files that are ready to be committed. Next thing you do is you git commit. So git commit, and if you just type git commit and enter, it'll like bring up a weird GUI where it asks you where your commit message is going to be. So if I quickly pull up the repo on GitHub again, and I look at the commit history, you can see that this is the history of this repo. Again, for the example, we assumed that it was a brand new repo, but I lied to you. There's been 7 commits on this repo since we made it yesterday. Each commit has some data about what happened in that commit. So as you can see, it tells you who the commit was made by, when it was made, the hash for that commit, which is kind of like an ID. And it also tells you the commit message. So this is the message that you're going to type in to let everybody know what this commit is all about. So that's where this comes in. So ideally, where's my terminal? There it is. What I'm going to do is I'm going to do git commit and then -m for message. I want to include the message directly here rather than, if I just do like git commit and then press enter, it'll bring up a weird GUI, blah, blah, blah. Don't want to do that. So I just use -m. I think you should always use -m. It's just easier to use. And then you want to, in double quotes, enter your message. So Shakib asked, what did he say? He said, not sure, is it okay if my commit messages are paragraphs? So there's a very huge, big convention about commit messages that they should be short, descript, concise, and to the point. There's a really good article on it, actually, and it seems like a really trivial thing. Like, who cares? Who gives a shit about my commit messages? I'm going to be looking at them, right? But it's kind of a habit that you want to be solidifying from the very beginning, because even later on, like these small things are like things that will carry on, and you won't notice them until other people that you're working with will point them out to you, and then you might be like embarrassed and awkward and like crawl into a little shell and something and like not talk to people for the rest of the day because you're embarrassed that your commit message is really shit at work. So it's a good thing to like get down from the very beginning. But yeah, Aiden said imperative mood. You always want your commit messages to be in the present tense. Essentially, your commit message should be as if you are telling Git what to do. So, or you can like also complete this sentence that I usually use, which is this commit will, and then underscore, and that's where your text would be. So like, so I'm gonna quickly add a new message here. So my commit message right now is adding new is even function. So as for example, this commit will add a new is even function. So that's kind of like what you want to do. That's a really easy way of like making sure you get commit messages chill. And again, you can have like detailed commit messages too. If you just type git commit and press enter, it brings up like a little screen where you can add text. The first line is the commit message, and then everything underneath that is like a description essentially. No one uses descriptions in git commits, like unless you're like really handling a specific project or something, but no one's really ever going to need to handle a description unless you're told to. So for the time being, we're just going to use a simple commit message like this right here. I'm going to press enter, and it tells you a bunch of stuff. It tells you it tells you the commit message you just made, and it tells you 2 files changed, 41 insertions, which is like how many things you added to each file total. And then you can ignore this. This is just like fancy Git stuff. Basically every file will create a new mode, but blah, 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 ignores that. So anyway, now if I type in git status again, you can see, I'm going to open up my code again, first of all. There we go. You can see right here, on branch main, your branch is ahead of origin main by 1 commit. So every time you've done git status before, it's told you like your branch is up to date, which is cool. But now it's telling me your branch is ahead, which means like we have changes that the original repo that we cloned from doesn't have, or that branch. And it even tells you use git push to publish your local commits, which is pretty nice that it tells you that, because the next command, if you want to guess it in chat, is git push. And git push again will push this change to my GitHub like repo. So if I go back to my GitHub repo real quick, I go to this repository and I refresh it. You can see that the last commit was an hour ago by Aiden. There's nothing here. Like we did a bunch of stuff, but it's not here yet. So like, what do I do? Why is it not here? If I type in git push, press enter, it'll take some time depending on your network speed, and it'll do a bunch of stuff. It'll tell you a bunch of these things that are fancy and you don't really need to know about them, and it'll tell you where it's pushing these changes to. It'll tell you like, hey, it's going to this URL, and it'll tell you this is the name of your branch locally, and this is the name of your branch on the repo over here. So if I go back here and I press refresh, does anybody want to guess what happens? I'm just going to give the chat like 10 seconds to guess. I wonder, can anyone guess what will happen? Anybody? Come on, guys. Nobody? Your internet goes down. It refreshes. Cool. Anyway, I'm going to refresh. Everyone gave me really shit answers. I'm going to refresh. And what would look at that. It's my name, my commit message 2 minutes ago. Now we're at 8 commits instead of 7. And you can see right here that my commit was added. And if you click on this, it'll give you a diff viewer, which is difference viewer. And I'll tell you what was added. It'll give you a really detailed description of what exactly happened. So it'll tell you like, hey, this new file was made. It had 39 new additions to it. And there's this new file made called test.py and it had these 2 files made into it. If I go back in time and then look at some stuff here, I can look at Aiden's commit. And I can see that he edited the readme file and deleted a bunch of stuff from it. If I go back to this right here, I can see that I also did the same thing for some reason. And if I go back to like this commit right here, you can see that Aiden made this file and added a bunch of stuff to it. So that's kind of like Git history, really cool stuff. So yeah, go back here. So I have this new, if I go to the source folder on here, you can see my code here too. You can see the test.py file, you can see the main.py file, and everything looks great, right? But let's just say, it's going to take me a minute to do because it's on this second monitor, but let's say you're working with a buddy, and your buddy thinks he's a better programmer than you, and he edits your code. He edits stuff on the function that you made. He edits and rewrites it, and maybe he thinks it's better, maybe you think it's shit, whatever, but he added something to it yeah, okay, cool. So gonna quickly do this. Cool. So now let's say I go back to my repo, and I'm like, whoa, look at that. Spooky row, update main py with better code. We were just talking about that scenario, and it just happened for some reason. So we're like, oh, okay, let's look at it. Why can't I log into my... Guys, stop asking me really annoying questions. Come on. Anyway, we're like, oh, shit, what's this? And you look at it, and you're like, whoa. He deleted a bunch of my code and added some of his own. And I'm like, okay, I want to look at this better on my computer. I don't want to look at it on GitHub because that's like awkward, right? I want to look at it in my VS Code, debug it properly maybe, right? And you're like, okay, I go back to my code in my terminal that I haven't touched since then, and I do git status. Now it tells you that your branch is behind origin main by 1 commit and can be fast forwarded. So, and it even tells you the command to use. But basically, it's telling you now that the repository on GitHub is ahead of what you have. There's stuff there that isn't on your local branch, and you should probably do something about it. So what we're going to do is we're going to pull those changes to my computer, right? If I do git pull, and I think this tab right here, by the way, in VS Code, if you are looking, it'll like give you up-to-date like information about your Git repository. That's like all UI based, so it's not like text based, just FYI. If you do not want to use the terminal, that's a thing. But anyway, git pull, press enter, boom, it tells you it did a bunch of stuff. It says it's fast forwarded, and now you can see that my main.py file has been edited by Spooky Row. My VS Code has a cool thing where it like tells you who edited what and when. So you can see like Spooky Row 2 minutes ago, this code is edited, and you can see there's a way better function than what I wrote for checking if a number is even. And yeah, that's kind of like how you'd manage like code that someone else is working on the same thing as you, and you want to pull it. That's kind of the idea, is you pull that change. There is other stuff too, like managing merge conflicts and stuff. But yeah, if I go back here and type in git status, you can see now your branch is up to date with origin main, nothing to commit, working tree clean. Everything's good. Next thing is, let's say I want to work on this and I like want to like work on something separate and kind of like show off how cool I am and stuff. You can make a new branch on the Git repo right here. Let's say I can make a new branch. So it says right here, if I click on this button, this shows me the list of all the branches on this repository. Let's say I want to make a repository called like really cool feature, for example. Really cool feature. I can type that in here, create branch, really cool feature, click that. And now I'm on this new branch, which is going to be a branch off of main. So it'll have all the same code for now, right? If I go back here and I go back here, you can see you can switch between both of the branches. You can switch between main. You can ignore this protected thing. Ignore that. I'm just going to X that for now. Who cares, right? Anyway, you can see I have 2 branches now, main and really cool feature. If I want to make sure that I can also look at those branches, let's say now I want to work on that branch on my computer. but I don't have that branch. I'm on main right now on my computer. How do I get to that new branch? So what I would do first is I would run git fetch. And what git fetch does is it doesn't actually give you any output most of the time. It just does it. Okay, did it there, right there. But what git fetch does is it looks at the entire repository on GitHub or wherever you are, and it kind of looks at what changed from the entirety of our repository on our computer and the entirety of the repository on GitHub, and it tells itself what the changes are. It doesn't do anything, but it tells itself, okay, these are all the things that changed. It's kind of like it pings the repository for all the changes from like when it was last updated. It gets them back and it just keeps track of them, but it doesn't actually edit any of your code. So it's a good way to figure out, instead of pulling, because what pulling does is it like actually takes the code and yanks it back into your computer and like overwrites your current code with it. Fetch will just kind of like tell you, oh, this is what changed, blah, blah, blah. So right here you can see it tells you from the URL git 101, there's a new branch that was created, and it gives you the name right here. This is the local name of your branch, so really cool feature, and this is the one on the Git repo right here. So now you know that, oh, there's a really cool branch. And let's say someone else, like let's say, let me quickly do this real quick. Let's say like the other guy who's kind of an asshole who like, you know, made that really bad code. Let's say he also makes a branch too, and you don't know that, right? You haven't looked at the GitHub repo or whatever. Maybe he made it while you were like doing something. You can do git fetch again, and you can see new branch was made again, called better feature, but we didn't make that, right? Like we never made that. As a matter of fact, Spoopy routed. So yeah, there you go. That's a cool way of keeping track of all these changes. But anyway, I digress. We go back to what we were trying to do, which is work on a really cool feature on the branch we created called really cool feature. If I refresh this really quick, you can see better feature right there. Anyway, we want to work on this branch right here. I go back to my terminal. I can do git checkout and the name of the branch. So in this case, it's called really cool feature. I think it'll be able to, no, it won't. Yeah, there you go. So checkout kind of, it kind of like moves between branches, checking out to a different branch. But it's kind of weird. It won't work if you currently have, if you're working on your branch right now and you have code that's sitting there, it won't just let you check out to a new branch because there's stuff that's been changed that hasn't been committed to anything yet. So ideally, you want to have everything kind of check out with my credit card. You could make the branch name your credit card information if you really wanted to, I guess. But yeah, you can't check out to a different branch if you have current changes like happening that haven't been committed. So every time you do check out, make sure you've either managed those changes, like make sure they're committed or something, or you've stashed them somewhere or whatever. So, but we'll go over that later. Anyway, git checkout really cool feature, press enter. And then it tells you branch really cool feature set up to track a remote branch really cool feature from origin. That just tells you, hey, I made a new branch on my local instance of the repository called really cool feature. That's what this is right here. And then it's set to track remote branch really cool feature from origin, which means that I've made this branch and it's linked to this branch right here on GitHub. That's essentially what that means. So if I go back to my VS Code and my terminal, now I am on this new branch. It doesn't really explicitly tell you in VS Code, not right off the top of my head. Here I think it will tell you that somewhere, but I don't remember where. But anyway, you're in this new branch now. Let's say add more code. I can add like a few more functions maybe, like is odd. So if I get, let's write this function real quick. Cool, I wrote this really cool, oh whoops, I spelled it wrong. Of course I did. I wrote this really cool new function. I maybe documented it too, because you know I'm a good programmer who documents their code, like that. And then same thing here. I document this code with some stuff too, like that. So I added a bunch of comments. I added a new function. Blah 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 blah. How does my code autocomplete? What a good question. I have this thing called GitHub Copilot. For anybody who's starting out programming, GitHub Copilot is like super useful. And look into it. It does use AI for auto completion, so it is a bit iffy, but it's pretty useful most of the time. But anyway, I added this new function to my code, added some new comments. Let's also say that I wanted to add new changes to my README. So if I was like, perfect, it's auto completing some stuff for me. It's not gonna do anything, bro. Okay, great. Cool. I just add some new like things, like, you know, maybe want to add some new commands to my README file or something. And maybe also, let's say I want to delete this test file because, you know, it's useless. Why is it here? I can delete that. And now I have all my changes done and I'm ready to go. if I do git status now, oh, I spelled it wrong. It even tells you when you're like stupid, and it's like, oh, this is the most similar command to what you actually typed. That's pretty cool. Anyway, you type in git status, and you can see now we're on branch. Really cool feature. It tells you the branch is up to date, so there's no changes on the branch on GitHub that we haven't had yet. And these are all the things that have been modified or deleted or edited, and you might want to stage those and commit those. So as you can see, we modified README, we modified this file, and we deleted this file. Even on VS Code 2, which is really cool, it'll tell you like what's happening. So it'll tell you like README changed. This is what you edited. It'll tell you main.py. This is the diff viewer that we saw earlier on GitHub as well. It's a similar property where it'll show you the old version of the file that you before you changed it, and this is the new version of the file now that you've changed it. So and this one, this is a little D in red, and it's like strike through, which means it's been deleted. Pretty obvious. But yeah. So now that we have that over here, I'm gonna do git status again just to double check everything's good. Now I'm gonna add those changes. So I want to make 2 different commits first, right? I don't want to just add these all to the same thing because they're unrelated things. I edited the README file, I deleted test.py, and I edited main.py, and those are all very different things, right? So what I'll do git add README first. If I do git status again, you can see that this has been staged now because it's in green and these are still modified, but that's totally fine. I'm still going to commit this. I'm just going to git commit this with a message that says edit README file with more information. And then I'm going to enter that. And it says it's cool, everything's good, there's no errors or anything. If I do git status again, status, you can see that just disappeared from my screen, the green stuff, but you can see right here, your branch is ahead of by 1 commit. You just get pushed to publish your changes. I could get pushed right now, but I'm not gonna, because I'm just gonna commit all these changes and push them all at once. There's no big difference. You could push right now, but basically I don't want to push stuff so that the other guy who's coding on this project, who's a bit of a dick, I don't want him to see like I'm doing stuff as I'm going. I just want to be like hit him all at once with all my changes to like show how good of a programmer I am. So I'm not going to push them yet. So I'm going to make another commit now. I'm going to make a commit for this file right here, the deletion of test.py. So I'm going to do git add source test.py. Do git status again, and you can see now it's staged. Do git commit, and again, the more you do this, the more you realize there's actually like 4 commands that you really use all the time: add, remove, commit, push. Those are all the ones you're really ever gonna use for the majority of your like project work and like checking out and branching and stuff. But anyway, I'm gonna write a message called delete test.py because it was useless. And then I'm going to push that as well. Oh, I'm not going to push that, sorry. I was about to write git push. It's a habit of mine to always just type git push after. But I'm not going to do that. I'm going to do git status. And now you see that your branch is ahead of origin by 2 commits, because we have 2 commits now. Pretty easy. 1, 2. Pretty chill so far. And now we have 1 more file right here that we have yet to commit. So I'm going to do that. And since it's only 1 file now, I'm just going to do git add dot, because I'm like, I don't need to type the entire thing. There's only 1 file left to stage. Do that. And then do git status. And now you can see that this is the only file remaining and it's been staged. So now I'm going to write a nice commit message for it as well. And I'm going to call it, be like, you know, someone give me a cool commit message for the isOdd function. Someone give me a nice 5-word commit message. I'm going to wait for someone to respond in the chat. Please, guys, it's going to take a while. It's going to be really awkward if you guys don't say anything. Okay, I'm just going to type something. It's for you guys. I'm going to write add isOdd function to main. And obviously, in your code, when you're making code, your commit messages aren't going to be this like boring and like, obviously my code's not going to be like isOdd is even. It's going to be more conceptual stuff rather than telling people I added a function. It's going to be like, I added maybe this page to this website, or like add homepage to website, or add navbar to homepage. Like it'll be stuff like that. It won't just be like add this function to this file, because that's like useless, right? That's a perfect message. Add isOdd function to main. So that's, yeah, okay, to main. Perfect. I'm just going to do that. Perfect. Press enter. And now you can see 1 file changed, 14 insertions, 1 deletion. One more time, if I do git status, as you can see, now we are 3 commits ahead. And if we push it, you'll be able to see the changes on the remote repository. Just to double check, if we refresh this, there's still nothing here yet, right? We're still at the old commit message, update main.py with better code. So as soon as I push this right now, git push, it'll show you there's all this information. And even GitHub picks it up sometimes automatically. It'll pick it up that, oh, really cool feature says recent pushes less than a minute ago. So if I refresh this right now, you can see that it says it's added just 3 commits right there. If I go to the commits tab, you can see all my commits were just added. Edit readme file, delete test.py, and add is-odd function. So we all have those here. A really important difference now, though, is that we're on the really cool branch. If we go to main has not been touched since like a minute ago. Oh, wow, thanks, Aiden. You added a merge conflict. Cool, I didn't even realize. But yeah, as you can see the history right here, there's none of those things I just did are here. And Aiden said I forgot to git pull. I kind of technically did, but I didn't realize we were adding changes so quickly, But yeah, usually, ideally, when you're coding and you're committing stuff, you want to be pulling stuff too, especially if you know people are working on a project at the same time as you, specifically, because if they're working on stuff and you're working on stuff, you want to always make sure that if there is a conflict, you like get notified about it before rather than after, because by the time you find out later on, you guys have both wrote like 200 lines of code and you have to sift through all the merge conflicts. But if you just do it at the very beginning and like, oh shit, we're working on the same function, it's like a lot easier to be like, okay, maybe let's work on this and you work on that, So it's always better to do it sooner rather than later. But anyway, as you can see here, we have a merge we don't have it here, but we have it right here. So that's cool. And if I do git status, you can see your branch is up to date with origin, really cool feature. If I do git pull though, it'll see all this stuff right here. Git status, nothing's really changed. If I go back to main though on my computer, so if I do git checkout main, if I do git checkout main, so if I go back to the main repository on my computer, or my main branch on my computer, it'll tell me like, yo, you had a change that happened on GitHub and you didn't know about it. Like, your branch is behind origin main by 1 commit and can be fast forwarded. So if I go back to main, that is going to be this commit right here, because I didn't know it happened until I changed branch, right? So I'm going to do git pull, and now I have Aiden's change. So if I go to what change? Okay, he just wrote merge conflict. It's great, thanks. But yeah, you can see that his change right here got added, and you can even see my GitHub tells me like what line was edited by who. You can see that this right here was edited by me 60 minutes ago, but this was edited by Aiden 3 minutes ago. So yeah, Aiden said he's gonna break it now. Don't worry. So good luck with that, buddy. I'm gonna try to avoid merge conflicts today, I'll be honest. But yeah, that is the basics of like managing that stuff. I'm gonna quickly go back and see if there's anything I forgot. Oh yeah, merging stuff. Totally forgot about that. Right. So now I'm done. Really cool feature, and it's great. And I want to put it back onto main, right? Because maybe the other guy who's working on this project is seeing my new branch and he's like, whoa, this looks really cool. And I want to like push it to main or merge it to main before like, he even starts like thinking about other stuff, right? So I'm not going to use the command line for this, honestly. Other than managing your code specifically, when you're managing stuff on GitHub, it's always better to use the actual website. There is also a command line tool made by GitHub called GH, which lets you manage repositories and stuff, which is something you could also look into. But I don't know. It's just always easier to use the actual CL, like the UI on GitHub. So it comes up right here that says really cool feature has recent pushes 3 minutes ago, and it says this thing called compare and pull request. So essentially, when you want to merge something from your branch into main, you could just do that and like not let other people see your changes, but that's kind of like a scummy thing to do, right? The whole point of using version control is so that other people can also review your code before it gets like merged with their code and the main code and stuff like that. So what I'm going to do is I'm going to create a pull request, which essentially, if I open this up right here, there's a bunch of stuff that happens now, a bunch of cool things, right? That just show up on the screen. Basically what a merge request is, or a pull request, sorry, is you're opening up like a conversation to everyone working on this repository, and you're like, hey, I have this branch right here, and I want to push it into, I want to merge it into this branch right here, which is why the arrow is pointing to the left. I want to take the code from here and put it into here, right? So I'm gonna give this pull request a name, so I'm gonna call it added functions, or added a bunch of functions to main.py to improve math computations. And what I can also do is I can add people to review this merge request or pull request. So like if I want Aiden to look at this and like approve it for me, and I want Swoopy Rod to look at it and approve it to me as well, you can do that. That way you can like get feedback from other people. If people have like comments, they can leave comments on your pull request as well. I'm gonna assign this to myself. That's just a nice thing for other people to see. Like, oh, this guy is the one who's working on this pull request. That's cool. I'm gonna leave a little description maybe. I'm gonna say edited main.py. I'm just gonna leave a little description of what I did maybe. Deleted task.py and edited readme. I'm just gonna let people know what I did. Again, this would be the description formatting for pull requests is really up to you. There's some standards here and there that get used by different companies and different people. Oftentimes in a very complicated project, you'll have like issues that get tracked, and you'll talk about how those issues are being addressed in this comment. Some companies even have like templates that get generated that you fill out for your descriptions, but that's all like really complicated stuff. For now, it's kind of up to you with how you want to format your pull request. It's just good that you stay consistent within your project. So I'm going to create this pull request now, right here, and it's going to take some time, and I get brought to this screen right here. So, oh great, we have merge conflicts. Thanks, Aiden. I know this is you. So as you can see here, if you go to this repository right now, if you go back to this main page, again, this is just the default page. We have all these tabs up here, and most of the time you'll only ever be in code, but right now you can see we have a new pull request with the number 1 here. So I'm going to click on that, and you can see my new pull request that I opened just now with the name of it. Click on here, and you can see all the stuff related to it. So you can see that Aiden requested a change from me on this repository, on this pull request. He reviewed my code and he found something was a bit shitty maybe. So he wrote L conflict to it. And so thank you guys for that. And you can see right here, you can see what the files that were changed are in the entire, like all the commits that are in this pull request. You can also see the commits specifically here that I have as a part of this merge pull request, and you can see the conversation. So as you can see, right now I can't merge this. If I really wanted to, I could, but I'm not going to. There is permanently there's conflicts that must be resolved. So you can use a web editor or the command line tool to resolve conflicts. I'm going to resolve conflicts with this button right here. So this is kind of awkward. Right now, what is even the change? Oh, you just overrode it? Okay. So basically, somebody changed something that I was merging into, and now GitHub doesn't know, or Git doesn't know which one of those 2 changes to actually use for this part of my file right here. So in main.py, these like 14 to 24, lines 14 to 24 edited, and it doesn't know how to handle that. It's like, do I use your changes or do I use the changes Aiden made? I can't tell, because they're kind of like made at the same time. You didn't have them on your branch because you didn't pull enough. So now you have these changes that you made earlier, and then Aiden has these new changes. Which one do I use? Because they're both coming in at the same time. So in this case, I'm obviously going to use my changes because like I'm better than Aiden in this project. So I'm just going to go ahead and edit this. So it tells you right here so this is a really hard UI to explain. Basically, this right here describes all the code up to this equals line, I guess. This is all the code in your branch, and this is all the code in Aiden's change. Aiden pushed a comment. Aiden pushed a comment. He committed treason. But anyway, this is all the changes that Aiden made, and these are all the changes I made. And you can see that with this arrow with the name of the branch. And then you can see the equal sign here. And then you can see that on main, this is what Aiden put in there. So it's asked me, what do you want to do? Like, finalize what you want to do and let me know. So what I'm going to do is I'm going to delete this right here, obviously, because there's a text right here. Delete this. Delete that. I'm just going to keep it like this. This is what you want. Why not keep both changes? Listen to Juan. Just shut up, all right? Listen, all right? I don't want Aiden's changes here. The whole point is that this is my code and not his, okay? This other guy who's working on this project, I don't want him to see that I worked with other people, so that's my reasoning, right? Anyway, this is what the code I want to go with now. As you can see, there's no more like highlights of color like orange or whatever. So I'm good to go. So if I mark as resolved and commit merge right here, you can see now that there's been a new commit added, to my pull request, edit readme files. Oh, it's not this one. This right here. Merge branch main is a really cool feature. So you can see right here that I resolved that merge conflict. It's kind of, it tells you here too, you're viewing a condensed version of this merge conflict. You can view the full changes here. I'm not going to go there. Don't need to go there. But anyway, if I go back to the main pull request, you can see now that there's no more merge conflict. It says right here, this branch has no conflicts with the base branch. Merging can be performed automatically. So I could wait for someone to approve this code. So let's just say that, 1 second, let me pull up my alt account. That's totally not me, on a different account. Let's just say I told like the other guy who's working on this project to review my changes for me, right? And I'm like, hey, can you look at this code, make sure it looks good? And you know, he like goes ahead, does that for me. If I go back to this right here, if I just refresh this page, you can see that Spooky Rao has approved these changes. He wrote, looks good to me, and you can look at the stuff that he reviewed. In this case, he reviewed everything, which is great. These are all the files he reviewed. Everything looks good. He thinks it's all good, so we're good to go. If I just quickly click back here, there we go. So now that he's approved these changes, I feel more confident committing this to the main branch. I can go ahead and merge pull request, and this is the commit message that will show up on the main branch. Most of the time, you can leave this default if you're working on a small project or something, but oftentimes might be conventions in specific groups of people or specific companies, so you might want to follow those. But in this case, we're just going to leave a default. So it says merge pull request 1 from this branch right here. If I click confirm merge, it says pull request successfully merged and closed. So now all the changes from a really cool feature on GitHub have been taken, tested, made sure everything looks good, and put back into main. So if I go back to my code viewer, you can see right here I have a new commit on my main branch, even though I didn't commit anything to main yet. That's the merge that we just did. Oh, the pull request we just merged, sorry. So you can see right here, you can see some of the commit messages actually sprinkled between here that I had on that pull request. You can see right here, merge pull request number 1 from Laurier CS, really cool feature. And if I click this, you can see all the changes that were committed. And now if I go back to my main branch, should be right up to date with really cool features. As you can see, oh yeah, sorry, it's one commit behind technically because it was like merged, but yeah. As you can see, these have the same code and everything. And in this instance, like maybe I'm done with this branch, I've worked on it fully, and I don't need to work on it anymore. I can just go ahead and delete it. If I click on view all branches, your branch, really cool feature, I'm just gonna delete it. And now it's gone because I don't need it anymore, right? Like I made that change, it's all good to go, and I'm gonna push it back in. It's all good to go now, so I don't need it anymore. Branches sometimes are temporary because like they're meant to be worked on by people to be put back into main anyway. So you can always delete them. Some projects might have like hundreds and hundreds and hundreds of branches that are just stale or dead, which means they haven't been touched in a while. So it's always good to like keep your repository clean so that people aren't confused. But yeah, that is that. And I think that's basically all the concepts we want to touch over today. Oh, the one cool thing I guess we'll talk about, I completely forgot to before we call it there. We've talked about branching, checking out conflicts, fetching, pulling, status, add, remove, cloning. The one thing I want to talk about is a git ignore file. Really important concept actually. I don't know why I covered it last. This is actually one of the most important concepts in GitHub. Very simple though. Let's say in my code I have this file that has like a key, an API key, or it has my date of birth, or it has something really, really, really sensitive that I don't want people to see. I'm just going to call it, there's a convention called .env, which is basically, let's say if you have an API key that you are using for a project that you got by making an account on some website, and you don't want to leak that API key because it's private, or it's like a token or whatever it is, right? Let's just say I put like super secret. The actual contents of this file don't matter. This is just like .env, like this could be any file. But let's say I have this file called .env that has some super secret info in it, and it's called like, you know, that or something, right? Let's have this new file in my repository, but I don't want to just push it onto GitHub, right? I want to like make sure that it's private, but I still have it locally. So what you could do is this file called git ignore. So if I just type in .git ignore, you can even see the icon changes. If I make this new file, any names of files that are in this file, Git will ignore. So let's say I don't want it to track any changes in .env because that's some sensitive information. Because right now, if I go to git status, you can see that it's tracking .env and .getignore is changes that and I don't want it to track .env, right? Because it has some private sensitive information in it. What I can do is I can go ahead and just do this in here. I can give it the name of the file that I want to ignore, in this case .env. And if I go back to git status over here, you can see that it is only tracking getignore now, right? And .env has disappeared. Also, little cool tip that we just talked about. You can see that my branch is behind by 6 commits because I haven't pulled in such a long time. I'm gonna go ahead and git pull real quick. There we go. Cool. Now we're up to date again. If I do git status, up to date. And again, we don't have .env in here, but it is in here. It's super secret information. And what if the file isn't in the same level? That's a really good question. So if I have a file in here in this folder, let's say I have this folder right here. I make a new folder in here called secret, and I make a new folder in here called info, and then I make another file in here called secret stuff ._stuff.py with some text in here. Let's have this file right here, and I don't want to like commit this either, right? Because if I do git status right now, you can see that file too. You can see source secret. What you can do is you can just add. There's 2 different things you could do. There's one, you could do source secret info secret stuff.py, which should also work. What you could also do is if you want to hide this entire folder, which is what I'd recommend in this case, I would just do this, and this will just keep this folder a secret. So if I do git status right now, you can see that there's no secret folder being tracked, right? And if I just make this go a bit further, maybe if I do info like that, git status, you can see that it's not being tracked. And that way I can make a new folder in secret called like test, and make a new file in here called test.py or something with more random text. And as you can see, secret has 2 folders in it, info and test. And if I do git status, you can see the server's secret folder. If I go into that right now, if I do git add dot and then do git status, you can see that this file got added to my thing, which is totally fine. That's what you want. But this file, the info file with secret stuff in it, this has not been added. So that's a good way that you want to maybe add files that you don't want to push onto the internet. And that's what if I want to hide all Python files. So let's just say you want to completely ignore all your Python files that you're working on right now or something. Or let's say you have this new file type called .java or something, and you want to ignore all your Java files. What you can do is you can type *.java, and this will just ignore every single file that has .java at the end. And yeah, you can use like some patterns matching in your git ignore to make sure that, like, you know, certain types of files don't get added or something. What if I want to ignore files with a certain file name pattern? Sorry, that's what I answered, I guess. I'm just gonna sorry, I didn't realize you asked the same question. But yeah, that's how you'd like ignore certain files with certain file types, or ignore certain files in certain folders and stuff like that. So if you go to the Laurier CS website real quick, as an example, website, we can look at the git ignore in here, and you can see it's pretty big. All of these files are being ignored. So in this case, the logs folder is being ignored, anything that ends with .log is being ignored, and all of these things are being ignored. So yeah, good thing to have, really cool thing. Oftentimes everyone's had this instance where they've leaked an API key that they've been working on for the first time. Maybe you're working on a Discord bot, and the API key for the Discord bot was get ignored, and you accidentally pushed it, and you get an email from Discord saying, whoop-de-doo, it's on GitHub now. So that's pretty normal thing that happens to everybody at least once. So yeah, cool thing to know how to use and stuff. But that's basically everything I can think of for this demo that we wanted to cover. Before we call it though, I'll quickly end the presentation real quick. Unless anyone has any questions, like that's the next slide I think right now. If anyone has any questions. We'll also drop the repo link in case anyone wants to look at like what we did throughout this and see what happened. But yeah, that's basically all the concepts. If we want to quickly go through them again, we learned how to create a repository, how we manage files through GitHub. We learned how to clone stuff. We learned how to also check the status of your repository, add files to the stage, remove stuff from the stage, and commit stuff. We also learned how to use the fetch, pull, and status commands again, like over and over again. Learn how to use git ignore, learn how branches work, how to check out stuff, and how to manage merge conflict. And also, all that stuff is like a lot of information, a lot of words. It's not easy to learn Git straight away. It might be like an easy concept, but like once you actually do it, you're like, oh shit, where do I start? What do I do? So don't like feel too threatened about like not knowing what I just did. As long as you get the overall idea of how Git works, the commands themselves are like whatever. You'll learn those. Like there's a cheat sheet for it as well online. I quickly Google Git cheat sheet. There is one right here, made by GitHub themselves, which documents every single command. I think also Atlassian has a web page that documents every single command as well. And you can see like this has a lot more files that a lot more commands I didn't cover, like git log, stashing stuff. This has the ignoring stuff with git ignore, how to rewrite the history. So if you want to like go back in the history of a repo, maybe you don't like how the commits are made or something, you can rewrite history as well. Something we can't do in real life. And yeah, that's basically it for today. We didn't go into a lot more concepts, but we are going to do a more complex workshop in the future called GitHub 102, maybe, depending on like feedback and stuff from people. But we'll have more advanced concepts about GitHub and Git and GitHub specifically. Like again, how to rebase, how to like manage timelines, how to do all that stuff. So yeah. Otherwise, that's it for today. Make sure to follow us on our socials. That I'm just gonna pull the slideshow right here. And if anyone has any questions, they can drop them. Also, don't forget to sign in to the event, which the link should hopefully be dropped by someone in the chat soon-ish. If you're a Laurier student, make sure you sign in. But yeah, that's basically everything. We have some upcoming events too. Make sure you stay tuned to our Discord and stay up to date with all that. But yeah, if no one has any questions, I'll give it 1 minute. There's a sign-in link. Thank you, Torin. If no one has a question within 1 minute, we're gonna call it. Cool. All right. Well, I guess that's it. Thanks for tuning in. This will also be uploaded to YouTube, so if you want to follow along again, you can. But yeah, thank you for watching, and see you all next time.